Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Amazon CloudFront and AWS Global Accelerator are both edge services designed to improve performance, resilience, and security. But they approach these goals in different ways. CloudFront focuses on caching and distributing content at edge locations around the world, reducing latency by serving users from servers geographically close to them. Global Accelerator, in contrast, accelerates any TCP or UDP traffic by routing users through AWS's global backbone network to the nearest healthy endpoint. Together, they address two sides of the global performance challenge: delivering web content quickly and ensuring reliable, low-latency connectivity for applications. Thinking of them as complementary is helpful. CloudFront excels at optimizing HTTP and HTTPS, while Global Accelerator strengthens performance and resilience for broader network traffic. CloudFront is built around distributions, which define how content is delivered and from which origins. An origin can be an S3 bucket, an application load balancer, or even a custom HTTP server running on EC2. Distributions let you configure multiple origins and map them to specific path patterns. For example, static content like images may come from an S3 origin, while dynamic requests route to an ALB. Cache behaviors fine-tune how CloudFront treats different requests, setting rules for caching, allowed methods, and security. This flexibility allows applications to combine static and dynamic delivery under a unified distribution, ensuring both performance and consistency. It's a model that mirrors modern websites and APIs, where multiple back-end sources support a single user-facing domain. Cache behaviors are one of CloudFront's most powerful tools, allowing administrators to define rules based on path patterns. For instance, /images/* might have a long TTL, caching files for days, while /API/* might bypass caching entirely to ensure real-time responses. TTLs, or time-to-live values, control how long objects remain in edge caches before being refreshed. By adjusting TTLs, organizations strike a balance between performance and freshness. Longer TTLs reduce load on the origin and improve speed, while shorter TTLs ensure rapidly changing content remains up to date. For example, a news site might use long TTLs for archived articles but very short ones for the homepage. These behaviors ensure caching supports the workload's needs without sacrificing accuracy. Controlling access to origins is critical, and CloudFront provides mechanisms for doing so. Origin Access Control (OAC) is the modern method for securing private S3 buckets, replacing the older Origin Access Identity (OAI). OAC uses signed requests with stronger integration to enforce that content can only be served through CloudFront, preventing users from bypassing it and hitting the bucket directly. This pattern is common for private media or software downloads, ensuring requests pass through caching, authentication, or security layers first. While OAI is still supported, OAC is the recommended standard, providing improved flexibility and compliance alignment. In practice, OAC turns CloudFront into both a performance booster and a security gatekeeper for private content. For content that must be tightly controlled, CloudFront supports signed URLs and signed cookies. These mechanisms allow only authorized users to access resources for a defined period. Signed URLs work well for granting temporary access to specific files, such as a document or video. Signed cookies, on the other hand, apply across multiple files, making them suitable for streaming or bundled content. For example, an e-learning platform might issue signed cookies to grant students access to course videos for 48 hours. These tools add fine-grained security to content delivery, ensuring only intended audiences can reach sensitive resources. They align with use cases where content protection is as important as performance. Geo-restrictions allow CloudFront to enforce compliance and licensing requirements by controlling where content can be served. Organizations can configure allow lists or block lists based on countries, ensuring content is only available in approved regions. For example, a media provider might restrict access to certain shows based on regional licensing agreements. This geographic control is enforced at the edge, preventing requests from reaching the origin unnecessarily. Combined with other routing policies, geo-restrictions provide an additional layer of governance, ensuring compliance while still leveraging CloudFront's global performance advantages. They underscore how content delivery often involves legal and regulatory dimensions, not just technical concerns. CloudFront integrates seamlessly with AWS Web Application Firewall, or WAF, enabling security controls at the edge. Instead of exposing origins directly to malicious traffic, WAF rules block or filter threats before they reach back-end resources. Common protections include blocking SQL injection attempts, cross-site scripting, or abusive bots. For example, an e-commerce site might use WAF with CloudFront to stop automated scraping of product catalogs. Running these protections at the edge reduces load on applications while improving security posture. This integration reflects AWS's broader approach, combining performance and protection in a single managed service layer. Visibility into content delivery is provided through real-time metrics and logs. CloudFront integrates with CloudWatch, providing metrics like cache hit ratio, request counts, and error rates. Logs offer detailed request-level insights, useful for analyzing user behavior or troubleshooting. For example, if cache hit ratios fall unexpectedly, logs can reveal whether new query parameters are bypassing caches. Monitoring these metrics ensures organizations can tune cache behaviors for both performance and cost. Without visibility, administrators would be blind to inefficiencies or threats. With it, they can continually refine delivery, balancing speed, cost, and security. CloudFront supports modern web standards such as HTTP/2 and HTTP/3, which improve performance through features like multiplexing, header compression, and better handling of unreliable networks. These protocols reduce latency and improve user experience, particularly on mobile devices and high-latency connections. For example, HTTP/3's use of QUIC allows faster recovery from packet loss, benefiting global users with less reliable connectivity. By supporting these standards natively, CloudFront ensures applications remain current with evolving web technologies, delivering optimized performance without requiring back-end changes. This reflects the service's role as not just a cache but a modern content delivery network. Pricing in CloudFront is influenced by factors like price classes and cache hit ratio. Price classes allow organizations to restrict which edge locations serve their content, trading off performance for cost. For example, a business targeting only North America and Europe might limit edge distribution to those regions, avoiding charges for Asia-Pacific locations. Cache hit ratio directly impacts cost efficiency. The more requests served from cache, the fewer origin fetches incur data transfer charges. By tuning TTLs and cache behaviors, organizations maximize cache hits, reducing costs while improving user experience. This demonstrates how performance and economics are tightly intertwined in content delivery. Origin Shield is an advanced feature designed to protect origins from excessive load. It introduces an additional caching layer at a chosen regional location, consolidating cache misses from multiple edges before they reach the origin. For example, during a global product launch, instead of thousands of edge locations hitting an S3 bucket simultaneously, requests funnel through Origin Shield, reducing strain. This improves both origin resilience and cache efficiency. By acting as a buffer, Origin Shield makes content delivery more predictable and scalable, particularly during flash events or global spikes. It illustrates how CloudFront goes beyond caching into intelligent traffic management. Developers can customize CloudFront behavior further with Lambda at Edge and CloudFront functions. Lambda at Edge allows running serverless functions at edge locations, enabling tasks like header manipulation, authentication, or request rewriting. CloudFront functions provide a lighter-weight option for simpler transformations, such as URL redirects or header adjustments, with lower latency and cost. For example, a site might use CloudFront functions to normalize user agent headers, while Lambda at Edge performs custom authorization logic. These tools make the Edge programmable, transforming CloudFront into a platform for customization, not just distribution. They highlight the trend toward moving logic closer to users for performance and security benefits. A common and secure pattern with CloudFront involves placing it in front of private S3 buckets. By restricting direct access to the bucket and only allowing CloudFront to fetch objects, organizations prevent users from bypassing caching, signed URLs, or WAF protections. For example, a video streaming service might store files privately in S3, but CloudFront distributes them securely with signed cookies. This pattern ensures storage remains protected while users enjoy fast, global access. It reflects AWS's philosophy of combining services into secure, optimized architectures, where each layer reinforces the other. Global Accelerator differs from CloudFront by focusing on network-level acceleration rather than content caching. It provides anycast static IP addresses, which remain fixed even if backends change. These IPs route user traffic onto AWS's global backbone network, bypassing congested public internet paths. For example, a financial trading application can provide clients with stable IPs that always route them to the nearest healthy AWS endpoint. Unlike CloudFront, Global Accelerator supports any TCP or UDP application, not just HTTPS. Its strength lies in reliability and performance for latency-sensitive workloads where caching offers no benefit. Within Global Accelerator, the architecture consists of accelerators, listeners, and endpoint groups. Accelerators provide the static IPs users connect to, listeners define protocols and ports, and endpoint groups map traffic to regional targets. Health checks ensure endpoints remain responsive, and traffic dials let administrators control the percentage of traffic routed to each region. For example, a global multiplayer game could use Global Accelerator to route players to the nearest region but adjust traffic dials to shift users during maintenance. This design makes Global Accelerator both predictable and flexible, supporting performance and resilience in equal measure. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. When choosing between CloudFront and Global Accelerator, the first consideration is the type of traffic. CloudFront is optimized for HTTP and HTTPS workloads, where caching and edge-based security features dramatically improve user experience. Websites, APIs, and media distribution benefit most here, especially when static or semi-static content can be served directly from edge locations. Global Accelerator, by contrast, shines with non-HTTP traffic, such as gaming, VoIP, or custom TCP/UDP applications. It doesn't cache data but accelerates network paths by routing traffic onto AWS's global backbone early. This distinction is vital. If the need is faster, more secure web delivery, CloudFront is the choice. If the need is low-latency network connectivity for diverse protocols, Global Accelerator is more appropriate. Both services contribute to resilience, but in different ways. CloudFront supports multi-origin failover, where requests can be routed to secondary origins if the primary becomes unavailable. For example, a distribution may send requests to an S3 bucket by default, but automatically fail over to an ALB if the bucket fails. Global Accelerator uses health checks to detect endpoint issues and reroutes traffic to the next healthy endpoint in seconds. A gaming platform using Global Accelerator could maintain uptime even if one region goes offline, as players are seamlessly redirected. In both cases, resilience is built into the fabric of traffic management, but the mechanisms reflect their different layers of operation. Dynamic content presents challenges for caching, but CloudFront provides tools to optimize even these workloads. Cache keys can include query strings, headers, or cookies, allowing finer control over what is cached and when. Compression further reduces latency for dynamic responses, while short TTLs ensure freshness without eliminating caching benefits entirely. For example, a news site can cache headlines with very short TTLs, ensuring updates propagate quickly but still reducing backend load. CloudFront's ability to blend caching with dynamic delivery allows developers to tune performance without sacrificing accuracy. This demonstrates how caching can serve even workloads traditionally seen as uncacheable. Security at the edge is another advantage of CloudFront. By adding custom headers, validating tokens, or enforcing HTTPS, it ensures only legitimate traffic reaches the origin. Lambda at edge, or CloudFront functions, allow developers to inject security logic close to the user, such as rejecting requests, missing authentication tokens, or normalizing URLs. For example, an API gateway behind CloudFront could require signed headers validated at the edge before the request is forwarded. This reduces attack surface and offloads verification from backend servers. Security at the edge not only speeds up enforcement, but also distributes protection across AWS's global footprint. API protection is a common use case, with CloudFront and AWS WAF working in tandem. APIs exposed to the Internet are frequent targets for abuse, including injection attacks and brute force attempts. By placing CloudFront in front of APIs and integrating WAF rules, malicious traffic can be filtered before reaching the origin. For instance, WAF might block requests with suspicious query parameters, while CloudFront caches legitimate responses, reducing strain. This pattern transforms DNS and content delivery into a robust security perimeter, ensuring performance and protection work together. APIs thus remain both responsive and resilient against common threats. Observability is crucial for managing global edge services. CloudFront provides metrics such as cache hit ratio, origin fetches, and error rates, while Global Accelerator tracks endpoint health, latency, and traffic distribution. Anomalies like falling cache hit ratios or increased failover events can signal misconfigurations or backend issues. Cache invalidations let administrators remove outdated objects immediately, ensuring users see current content. For example, invalidating cached product pages after a price change guarantees accuracy without waiting for TTLs to expire. Observability turns these services into transparent systems, where performance and reliability can be continuously monitored and improved. Cost optimization requires careful tuning of both CloudFront and Global Accelerator. In CloudFront, TTLs influence cache hit ratio, and longer TTLs reduce origin fetches but risk stale data. Price classes allow administrators to limit edge coverage to specific regions, reducing expenses if global reach is unnecessary. Compression reduces bandwidth usage, lowering transfer costs. Global Accelerator costs reflect data transfer across the AWS backbone and endpoint usage, which may be justified for high-value, latency-sensitive workloads, but less for general web delivery. By aligning features with workload needs, organizations ensure edge acceleration delivers business value without runaway costs. Latency considerations often involve trade-offs between regional edges and origin servers. With CloudFront, caching static and semi-static content at the edge minimizes round trips to the origin. For dynamic content, routing through the closest edge still provides performance benefits by using AWS's optimized backbone to reach the origin. Global Accelerator, meanwhile, ensures even TCP handshakes traverse the fastest paths. For example, a multiplayer game benefits from Global Accelerator reducing jitter and latency, while its website leverages CloudFront for fast content delivery. By understanding these trade-offs, architects can combine services to optimize both web and non-web experiences globally. Compliance is increasingly important in global architectures, and both services offer features to help. CloudFront supports geo-restrictions, ensuring content is only served where licensing permits, while Global Accelerator provides routing controls through traffic dials, letting administrators shape how much traffic enters specific regions. These features make it possible to respect data sovereignty requirements and ensure applications align with regional regulations. For example, a healthcare platform might restrict sensitive data access to within the EU, while routing general content globally. Compliance is thus enforced at the edge, reducing risks before traffic even reaches application infrastructure. Common pitfalls often stem from misconfigurations. Leaving S3 buckets public when used with CloudFront defeats the purpose of OAC, exposing data directly. Misusing TTLs can cause either stale data to persist or cache misses to overwhelm the origin. In Global Accelerator, failing to configure endpoint health checks properly can prevent failover from working as intended. Each pitfall highlights the need for disciplined setup and ongoing monitoring. Avoiding these mistakes ensures edge services fulfill their promise of performance, resilience, and security. Performance testing at the edge requires a different methodology than testing origins directly. Tools should measure latency from diverse geographic locations, capturing the benefits of CloudFront or Global Accelerator's global presence. For example, load testing a web application solely from the US may hide latency issues for users in Asia. Incorporating global test agents reveals how routing policies perform worldwide. This ensures edge optimizations align with actual user experiences, not just local metrics. Testing confirms that investments in edge services translate into real improvements for end users. From an exam perspective, the queue is often distinguishing when to use CloudFront versus Global Accelerator. If the workload involves HTTPS content, caching, or edge security, CloudFront is the right choice. If the requirement is accelerating TCP or UDP applications or providing static anycast IPs with fast failover, Global Accelerator is the answer. Some questions may blend scenarios, such as delivering a global API with caching. CloudFront fits there. Others may describe low-latency multiplayer games, pointing toward Global Accelerator. Recognizing these distinctions ensures exam success and prepares you for real-world decision-making. Disaster recovery designs often combine Route 53 with Global Accelerator. Route 53 directs traffic at the DNS layer, while Global Accelerator manages traffic at the network layer, rerouting users instantly if endpoints fail. For example, during a regional outage, Route 53 can reroute DNS, but Global Accelerator ensures open connections fail over quickly. Together, they form a layered DR posture, providing both DNS-based redirection and real-time failover. This combination highlights how edge services complement one another, aligning performance with resilience. Finally, documenting edge patterns ensures repeatability and governance. Standardizing configurations such as secure S3 with OAC, WAF integration, or blue/green deployments with weighted routing helps teams apply proven patterns consistently. These catalogs reduce errors, accelerate deployments, and provide a shared vocabulary for architects and operators. For learners, studying these patterns provides both exam readiness and real-world preparation, turning abstract features into concrete solutions. Documentation reinforces that cloud design is not just about technology but about repeatable, reliable practices. In conclusion, CloudFront and Global Accelerator work together to improve global application performance and resilience. CloudFront caches and secures HTTP traffic at the edge, reducing latency and offloading origins. Global Accelerator provides static anycast IPs, health-checked failover, and optimized network paths for TCP and UDP workloads. Both integrate with AWS services to enhance security, observability, and compliance. By understanding their differences and complementary roles, organizations can build architectures that are faster, safer, and more reliable worldwide. For exam preparation, the key is recognizing which service fits which scenario, ensuring the right tool is applied to each requirement. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.